I'm Anil Kumar, and here is question number 5, a practice question for a test on rational functions, level 1. The question is, determine domain, describe discontinuities, find asymptotes, describe behavior of the graph near the asymptotes, and then sketch the graph of the function. Function is f of x equals to 4x plus 12 divided by x squared plus x minus 6. In one of my earlier videos, we did the sketching, but I told you that behavior near the asymptotes will be discussed later, and this is the video which you should watch for the behavior near the asymptotes also. So let's look into the function. It is f of x equals to 4x plus 12 divided by x squared plus x minus 6. First step should be to factor the function, right? So let's factor. You can take 4 as a common factor in the numerator. You get x plus 3. As far as the denominator is concerned, product of minus 6, sum of 1. That means opposite signs. X, bigger number is positive, plus 3 times x minus 2. And now you could actually cancel these factors which are common, and you get 4 over x minus 2, right? So you get 4 over x minus 2. Now the question is, if I write like this, then are these two functions same? The answer is no, since I have not specified that x is not equal to minus 3. Adding restrictions is very, very important, right? Let me emphasize that, right? So once we do this, we have to write where x is not equal to minus 3 and minus 3 and 2, right? So I'm just squeezing it in here, right? So this now this part of rational function is exactly same as where we started with, correct? Now let's understand all of the terms. Domain is all real numbers except for the restrictions which we just said. So we say domain of this function is x belongs to real numbers where x is not equal to these two values, which is minus 3 and 2. Describe the discontinuities. Now whenever you cancel out, we have a whole. So one discontinuity is a whole, which is at x equals to minus 3. The other one is a vertical asymptote, right? So the other one is vertical asymptote, which you can see is at x equals to 2, right? So that is the discontinuity. Now find asymptotes. Now the asymptotes here, as we have written already, vertical asymptote x equals to 2. So as far as discontinuity is concerned, that is a discontinuity. So discontinuity at x equals to 2 and vertical asymptote x equals to 3. Now it says find the asymptotes. Now vertical asymptote is x equals to 2. The horizontal asymptote, degree of numerator is lesser than that of denominator, and therefore the horizontal asymptote will be at y equals to 0, right? So that becomes the horizontal asymptote. Now it says describe behavior of the graph near the asymptotes, right? So let's get into that portion now. So let me make a rough sketch here for the purpose of describing the behavior near the asymptotes. One is x equals to 2. Let me just sketch this as a vertical asymptote at 2. Horizontal asymptote is 0, y equals to 0, right? So that is your horizontal asymptote. Okay. This point is 2. Now, if I write x equals to 0, what is f of 0? Let's see. What is f of 0? It's an important point. We get 4 over minus 2, right? Which is minus 2. So at 0, we are looking for a value which is 2. So that is the y-intercept. Is it okay? So that is the y-intercept. I'm sorry, minus 2. Minus 2 is the y-intercept. So that gives you an idea that this is your horizontal asymptote, that is a vertical asymptote, and that is a point on my graph. So basically, we are looking for something like this. Do you get an idea? So we are looking for, let me make it in a color which is lighter. So we have something like this as kind of a graph. Do you see that? From the given situation, correct? So I'm just sketching this to tell you that even before you attempt to describe behavior of the graph near the asymptotes, you can make a guess, right? And now we'll describe. So let's first describe behavior near the horizontal asymptote, right? So let's do that. So if x is approaching positive infinity, right, then what happens? That means a large x value, then this fraction will be positive. So y approaches 0, and since this is positive, you can just put 1000 there, you get a positive number, we say plus. From above, so you see this approaches from above. Do you see that part? So that is the behavior we're talking about. The graph of the function approaches from above as x approaches positive infinity. What happens when x approaches negative infinity? If I write a negative number here, large, we'll get 4 over negative number. So y will approach 0, but from below. So this approaches from, do you see this part? Approaches from below. So this is how you have to describe. So when x is approaching positive infinity, the graph of the function approaches from above, right? And when it approaches from negative infinity, the graph of the function approaches from below. So that is one part. So this is how we could describe horizontal asymptote behavior near horizontal asymptote. I should have written, right? Okay. Let me just divide this page again. Fine. Now let's discuss the vertical asymptote, right? So let's write near vertical asymptote, right? So let's discuss this part. So you could approach 2 from left to right. So what happens when x approaches 2 from left side, which is minus? That means you can substitute a value which is slightly less than 2. For example, you could say 4 over 1.9 minus 2, right? So as soon as you say 1.9 minus 2, you get negative large value. Is it okay? So it goes negative large. So we say y approaches negative infinity. Do you see that? So that is how you'll find, right? So now you could check from this side also, that is when x approaches 2 from the positive side, then you can just substitute a value here. So y equals to 4 over, let's say 2.1 minus 2, right? So that gives you a positive value. Do you see that? So you can say that y approaches positive infinity, positive large value. So you can see this, y approaches positive infinity when approaching from the right side, y approaches negative infinity when approaching from the left side. Correct? So that is how you have to describe behavior of the graph near the asymptotes, and then sketch the graph of the function. So the sketch is there, good points to write. Of course, the intercepts also. So we substituted 0 and we found the value is minus 2. So this is a good point to highlight. And the other good point could be just write x equals to some values here, and you could get some points here. Is it okay? But that's not very critical. Okay, these are few critical things to highlight. So we have highlighted hole, which we have to still mark on. We have a hole at x equals to minus 3. So let's find the value of this function at minus 3. So if I write minus 3 here, I get 4 over minus 3 minus 2, which is 4 over minus 5, or minus 4 over 5. Is it okay? Slightly less than 1. So at x equals to minus 3, this is minus 2, this is minus 3, we have to make a hole here, right? So now we can finally sketch our function. So we have a hole here, and now this becomes the graph of our function. Okay, and clearly mark this at minus 3, we have a hole. So we have a, let me write down hole, at minus 3 minus 4 over 5. Is it okay? So this is this hole. So that completes the sketch. Correct? So we know we have a hole here which should be highlighted. We've already done the vertical asymptote, which is right there, x equals to 2. Then we have a horizontal asymptote shown here, which is y equals to 0. And then we found an intercept, which is -2. And that's the calculation for the whole. That completes the graph for us, correct? Do you see that? So it is important to highlight all these critical points whenever you sketch a rational function, and behavior near the asymptotes should be described, and because I have very limited space, and written clearly. When x is approaching positive infinity, y approaches 0 from above. When x approaches negative infinity, y approaches 0 from below. When x approaches the vertical asymptote 2 from left side, y approaches negative infinity. When x approaches 2 from the right side, 2 plus, y approaches positive infinity. The graph will have a hole at -3, horizontal asymptote y equals to 0, vertical asymptote at x equals to 2. That helps you to describe and sketch the graph. I'm Anil Kumar, and I hope that gives you a good practice for your test. Thank you, and all the best.